Thread repair is a common issue that shows up at machine shops. A universally understood thread problem is stripped spark plug threads, and this doesn't seem to be limited to high mileage engines. I'm here with our XR650R Honda motorcycle, which was recently acquired with very low hours on the engine. The spark plug threads, as I discovered, had been sorely abused. Time-Sert has the ideal repair for spark plug threads. Aluminum heads and spark plug threads are vulnerable and can be easily stripped. The repair I'm about to demonstrate is not only a fix for damaged threads, it's also an improvement over original equipment threads in an aluminum cylinder head. Accessing the spark plug in this position can lead to trouble. The proper way to remove this spark plug is with the gas tank off, but in the field, the plug often gets pulled out and placed back in the threads on a very difficult angle. With the fuel tank removed, you can see that this plug access is tight. The threads, especially in an aluminum head, are vulnerable. The socket size for this spark plug is 5/8 of an inch. As you can see, the plug is difficult to access even with the fuel tank removed. With the spark plug barely loosened from its seat, this is the amount of movement. As I turn the spark plug about half of its threads outward, this is the amount of play between the spark plug and the cylinder head threads. As the spark plug reaches its outer threads, it's apparent that there is a problem here. Before I remove the spark plug completely, I'd like to show a technique that's worked well for me on spark plugs that go into awkward places, especially in aluminum cylinder heads. A piece of hose is a mild way to start a thread and can serve quite well. We're now looking down the spark plug hole, and you can see that the threads have been overused. The spark plug has been in and out of there so many times that the threads are loose. In this case, on the XR650R Honda, we'll use the Time-Sert repair kit to remedy this problem. The Time-Sert spark plug repair comes in a hard case. Tools consist of a tap that has two steps, one that is the original threads of the spark plug, and the second stage for the actual insert. There's an insert driver tool, and there's also a seat cutter that cuts a new seat or fresh seat for the spark plug gasket to seat on. The copper-coated steel inserts are specially designed. These inserts are actually 14 millimeter spark plug thread, that's 14 by 1.25 millimeters, and 16.8 millimeters in length for the 3/4 inch or 19 millimeter spark plug threads in this Honda motorcycle cylinder head. The first and very important step before using the tooling is to crank this engine over until the piston has come up on the compression stroke, past the top of the compression stroke, and drops slightly. This provides enough clearance with both valves closed and the piston below top dead center on the power stroke to enable threading and driving the new insert into the cylinder head without interfering with the valves or interfering with the piston. Before I run the tap in, I want to make sure that I have the piston down sufficiently in the cylinder. There's plenty of clearance for the threads, allowing the threads to drop 1/4 of an inch below the top of the spark plug seat. The valves are well out of the way, they're seated and closed, and we're running the tap first step down into the original spark plug threads. If these threads were damaged severely, there's even an oversized insert that can go into the head. But in our case, we're using the standard inserts and the first cut of the tap. Insert this tool over the top until it engages. As you can see, this is run down by hand. I could use the T-handle if I had enough room, but as you can see, there's not a lot of room here, so I will use a socket and center up on the top of this tool. This special ratchet made by Craftsman a long time ago. You'll see how I can stay on center as I'm actually threading the tap down into the spark plug threads and cutting the new threads for the insert. As these are aluminum threads, it doesn't take much effort to cut the threads, and I'm being very careful to keep the pressure on center as I work the ratchet. I'll take the second step threads to 1/4 inch below the top The aluminum threads cut readily, and those filings are going into the cylinder. We'll vacuum them out with a shop vacuum. Valves are closed, so we should have no trouble pulling these filings out of the cylinder. The lower step keeps the tap on center, as the upper step cuts the fresh threads for the insert. As you can see, we're cutting into the spark plug threads. The second step is well centered and is square as it goes down the threads. I apply pressure uniformly and evenly. I want to keep that tap right on center as I go down into the threads. I'm almost through the threads completely with the second step now. At a few points, I carefully backed the tap off to relieve filings and pressure and continued with the cutting. At this point, the tap is low enough that the second step of the tap, the threads for the insert, is almost flush with the top of the spark plug seat. I'll continue past the spark plug seat 1/4 of an inch to make sure that the tap is below the spark plug seat when I cut and trim the seat. The second stage tap threads are now 1/4 of an inch below the seat of the spark plug, and I can trim the seat at this point. Before I cut the new spark plug washer seat, I'm going to vacuum out this area. This tool serves two functions. It cuts a recess for the insert, and it also restores the spark plug washer seat. Our goal is to remove just enough material to create that recess for the insert and to just clean up the spark plug washer seat. Here the cutter is just starting to make the recess. After it completes that, it'll trim up the seat for the spark plug washer. Keep the tool from chattering. Hold it straight and allow it to turn smoothly without forcing it. And gradually work it down until you reach the seat for the spark plug washer and just trim that up. At this point, I'm turning the cutter by hand with a very light downward pressure on it. I just want to come down to the washer seat and trim it up. When I'm confident that the seat is square, I can apply more downward pressure with the T-handle. Make sure the tap remains below the cutting tool. Don't damage your tooling while you're doing this. Inspect your cut regularly. All you want to do is make a concentric, full washer surface. Here I've vacuumed away the debris so that I can get a clear sense for how the cutting tool is doing. You can see the taper for the insert seat, and we're just about to the point where we're going to be cutting the washer seat. Just starting to cut the seat for the spark plug washer. I don't want to remove too much material. The idea is to make the washer seat uniformly round, concentric, and approximately the same width. We want to get a good compression seal, and in order to do that, the spark plug washer needs to seat squarely and seal. I'm using a downward uniform pressure on the tool, keeping it square, not allowing it to chatter. I want a smooth seat, and I want it to be concentric. You can see how it's forming here. We still have a way to go. I just want to bring it around to a full circle, the proper width for the spark plug washer, and we'll have it. I'm rotating the tool strictly in a clockwise direction and applying uniform pressure downward. This would be the same repair that we would make to an automotive head. And think of how much time we're saving in not having to replace the head or remove the head for some other kind of repair. Now at about a 60% circumference of the spark plug seat. Keep the cutting tool centered, push down gently, no chatter, no excess pressure. We're just about there now. You can see how we're closing that gap on the freshly cut material. The tool is cutting smoothly. There's no chatter. This should be our final cut. Note how concentric this seat is as we close the gap on this side. We turn the seat cutter clockwise the entire time. Now you can see that we're almost 100%, and I'll go light downward pressure and a smooth feel as I finish up this seat. I'm turning the cutter by hand as I smooth out the final percentage of that seat. I just want this to be without chatter, moving freely. The cutter is, at this point, not resisting. I'm pressing lightly downward. I want to remove just enough material to establish a fresh washer seat, and no more material than that. And here we are with a fresh and concentric spark plug washer seat. It will get a good compression seal, and the insert will seat squarely in the tapered recess. Carefully remove the tap. Keep it aligned as you remove it. Protect those threads. This is the finished insert threads and the new seat for the spark plug washer. Note the quality of the threads and how square and concentric both the threads and the spark plug seat are at this point. Now we can install the insert. I take a final measurement of the depth of the threads just to make sure I'm using the correct insert. I don't want the insert to ride below the threads in the cylinder head. Time-Sert calls for using the Time-Sert driver oil on the tool that drives the insert into the spark plug threads. Make a point of using this oil. Thread the insert in until it seats in the taper. And the design of this tool is interesting. This driver will push through the internal threads until it reaches a point in the insert where the insert can be expanded slightly in an area of hard steel and press slightly against the threads to lock the insert into place. And we're now at this point ready to run the driver down through the internal threads of the insert. The goal now is to run the oiled driver down through the internal threads of the insert. When they reach the resistance point, continue turning. At that point, the insert is seated and expanded slightly to lock it into place against the external threads. When you can no longer feel pressure as you turn the driver down through the internal threads, the insert is seated completely, and you'll be able to back it out readily. We're at that point now where there's little or no resistance. Remember to use sufficient oil on the driver to prevent it from seizing as you back it out of the insert. If it seizes, of course, it would want to bring the insert out with it, which could damage the external threads. And this is the finished repair. Note that we have a fresh washer seat and that the insert is seated completely and flush with the washer seat. This is a Time-Sert repair and will make a permanent spark plug thread for this motorcycle engine. Many aftermarket head builders and performance engine builders install these Time-Serts. They are available for washer seat and tapered spark plugs. See the Time-Sert catalog for details, or visit Time-Sert.com online. We made this repair with the Time-Sert kit, and as you can see, the spark plug is turning readily into the new threads. It's a wonderful fit, and we know this is a permanent fix. I'll use a torque wrench now to torque the plug into place, and when we go to replace it, we know that it will come out readily and go back in readily. On this Honda XR650R motorcycle cylinder head, I'm torquing the plug to 160 inch-pounds, or just over 13 foot-pounds. That's plenty. As a footnote, Time-Sert suggests not using any kind of graphite or other lubricant on the spark plug threads. The special coating on their insert functions as a release agent to prevent spark plugs from seizing in their threads. This quick repair just saved over $300 in the cost of a new cylinder head casting. The Time-Sert spark plug repair can save you a lot of money and a great deal of time.